Okay, so for this problem, a block of mass 2 kilograms is placed on a trolley of mass 5 kilograms, moving horizontally. A force of 8 newtons is applied to the block, which slides on the surface of the trolley. The frictional force between the trolley and the ground is 0. The trolley then accelerates at a rate of 1 meter per second squared. It's asking us what is the coefficient of dynamic friction between the block and the trolley. Okay, so because it's asking us for the coefficient of dynamic friction, we might as well write down immediately the formula for this. Okay, so, well, we do know that friction, right, is going to equal to mu times n. Okay, I'm just using different notations, but you should have a formula like this. Okay, so the force is equal to your coefficient times your normal force. Alright, so going back to the problem, what can we identify here? Well, first of all, we're going to analyze this in terms of the object and the object alone for now. Okay, to simplify this. We know that there is a force of 8n to the right. So if an object is moving to the right, the corresponding, the reaction here is you should have the force of friction in the other direction. Okay, this is your force of friction. What else can we identify here? We also know that this object has weight, mg. Okay, now because there's mg, the corresponding normal force would be going up like this, and so our normal force would be in that direction. Okay, we also know, okay, that that this trolley is accelerating at 1 meter per second squared. Okay, now this is what might be a little tricky, is we need to identify another force, and that is between the object and the trolley itself. Okay, notice here that we have the force of friction of the object going to the left, right? However, there is also friction of the same magnitude that is acting against this block that is causing the trolley to move. Okay, so what does that mean? It just means that we have, if there's a friction force here, we have that same value, same magnitude of friction force that's actually going to the right and causing this trolley to accelerate, to move. All right, now the reason for that is because your initial forces, the initial forces that are being applied is on the block. All right, but this block, the fact that this block is moving, causes the trolley to then accelerate. So it's not just enough to identify the forces acting on the object itself, but because this is on top of a trolley that happens to be accelerating, okay, you have to identify what is the corresponding reaction between the block and the trolley. All right, and therefore this is what we have. Okay, now go back to the formula. Okay, well, actually before that, we can easily identify, okay, considering Newton's second law, we have F equals ma. Okay, the mass of the trolley is 5 kilograms. That's given in the problem. And we are told that it accelerates at 1 meter per second squared. Therefore, the force on the trolley is actually 5 newtons. Okay. Now we're going to use this value, plug it in here. Okay. So we know that your force is going to be 5. Okay, we just figured that out. We are trying to figure out my coefficient for dynamic friction. Now, what will I put for my normal force? Okay, well, my normal force is just m times g. I know that the mass of my object is 2. Alright, that's given in the problem. And I can also take the value of gravity to be 10, okay, or 9.81. But 2 times 10 would be 20. Okay, and now I can solve, and this will simplify to 1/4, which is the same as 0.25. Hence, my answer should be letter C. Okay, so the formulas involved in a question like this would be F equals ma, okay, Newton's second law, the force that relates the formula that relates force, your coefficient of dynamic friction, and normal force. But I think the most challenging part here is identifying the forces acting on this system. Okay, identifying the ones on the object would probably be okay, but if you fail to recognize this part over here, okay, that can cause a little confusion. So this is very important, especially if this were to be something similar on a paper 2 question. It would be necessary for you to correctly identify and know the forces acting. Okay, so there.